The moon has always been an object of fascination for mankind. It's a prominent view in our night sky, a moon massive and close enough that its beautiful and eerie details are visible with the naked eye. Mankind stepped on the moon over 5 decades ago, but to this day, there's still so much we don't know about it, as exploring any place outside of Earth is always incredibly dangerous and difficult. While the moon seems like a very different place from Earth, there's one thing that excites scientists about future colonization prospects. There is increasing evidence of water on the moon. But lunar water is mysterious. It does not always show up where we expect it, and by all accounts, it shouldn't be where we find it. Its mysteries are ones that the nations around the world are desperate to crack, because lunar water is the key that might unlock the solar system to us. Whoever solves it first will reap significant benefits. Where can we find lunar water? How do we know it's there? And how close are we to overcoming the moon's greatest dangers to get it? I'm Alex McColgan and you're watching Astrum. Join with me today as we follow the progress numerous space agencies around the world have made to find out once and for all whether the moon's surface contains water. Scientists did not always know that there was water on the moon. Luna 24 was an ambitious robotic probe of the Soviet Union in 1976. It successfully landed on the moon, drilled into the lunar surface about 2 meters deep, and sent about 170 grams of lunar soil samples back to Earth. Of greatest surprise to the scientists was the detection of water within the return sample. Around 0.1% of the sample was water, and they found that the concentration of water increased with depth. However, like the very trace amounts of water detected in samples obtained during earlier moon missions, for example Apollo 11, this was assumed to be a contamination from Earth. The question whether there is water on the moon remained unanswered. In 1994, NASA's Clementine mission showed that permanently shadowed areas that haven't received any sunlight in billions of years do exist near the moon's south pole. As a result of this, there was a lot of excitement in the science community about whether there could be frozen ice at the bottom of these craters, protected from the harsh rays of the sun, where the temperatures would never rise above about -173 degrees Celsius. Any water ice at the bottom of these craters could probably exist indefinitely at these temperatures. Excited by this discovery, NASA launched the Lunar Prospector spacecraft shortly afterwards in 1998, specifically to hunt for clues that water may exist there. While it didn't give us any conclusive answers to the mystery, it certainly added to the intrigue. The Lunar Prospector detected large amounts of hydrogen at the moon's poles using spectroscopy from orbit. Data from Prospector suggested that there could be somewhere between 10 to 300 million tons of water ice scattered inside craters around the lunar poles. But large amounts of hydrogen do not necessarily mean the presence of water. It could also be water's closest chemical relative, hydroxyl. The Prospector spacecraft subsequently crashed into the moon's south pole in 1999, with NASA scientists hoping the impact would blast ejecta into space, lit up by the sun, so that scientists could use spectroscopy to prove the existence of water in the dark craters of the moon using Earth-based telescopes. Unfortunately, no water ice was detected from the Lunar Prospector's impact. The mystery continued. Japan's Selene, or Kaguya spacecraft, was launched in 2007, and its mission was to take high-resolution images of the moon and map the lunar surface. But it also wasn't able to detect signs of water ice in permanently shadowed craters around the south pole of the moon. So, after 18 months of orbiting, it too purposefully crashed into the moon, hoping that this time it would release enough ejecta into space for Earth-based observatories to work with. But again, no evidence for water was found. In 2008, India's first moon mission, Chandrayaan-1, was launched. Chandrayaan-1 was different from previous missions in that instead of relying on sensors to detect water from a distance, India included an impactor that could specifically detect water in its gaseous form through spectroscopy as it came in close proximity to the spacecraft. Scientists believed water vapor could be in the extremely tenuous atmosphere of the moon just above these craters. The impactor probe was released from the main body of the spacecraft and descended for 25 minutes before it crashed near a crater at the south pole of the moon. As it descended, it sent the data back to the Chandrayaan-1 mothership, and within that data was the answer scientists had been looking for all these decades: a confirmation of water. And a few months later, the Moon Mineralogy Mapper instrument aboard Chandrayaan-1, using spectroscopy from orbit, also detected the presence of water on the moon. But NASA wanted more proof. They launched their own Lunar Crater Observation and Sensing Satellite mission, as well as the LRO, an orbiter you will be very familiar with if you follow this channel. LCROSS was a simple, low-cost, fast-track mission, and it had one main objective, which was to once and for all confirm the presence or absence of water ice in a permanently shadowed crater near a lunar polar region. It had a simple, straightforward, yet very clever design. In an unusual move, the first stage of the Atlas V rocket LCROSS was launched from stayed attached to the spacecraft, and upon reaching the moon, it was released to crash into one of the dark craters at the south pole of the moon. This impact was similar to how Lunar Prospector and Japan's Kaguya probes crashed into the moon to eject a debris plume that rose above the lunar surface. But unlike them, the LCROSS spacecraft itself flew through the debris and collected data without relying on Earth-based observatories, which clearly weren't very reliable for studying small plumes of debris. As the debris cloud rose above the crater's rim, it was exposed to sunlight, and any water ice and other molecules of interest were vaporized and broken down into their basic components, which the sensors on board LCROSS were able to detect, only for it to crash into the moon too after accomplishing its task. This combination of collisions produced a large plume of surface material, which the LRO was left to study. As LRO traveled over the lunar surface, it began to notice something unexpected. Trace amounts of water molecules could be found over the top of the surface regolith, the grey rock that makes up much of the moon. It turns out the whole moon is ever so slightly wet. This wetness was even observed to move around in a sort of lunar water cycle, both by region and by time of day. Around noon, when the moon's surface was hottest, the water seemed to dissipate, but then would return with the evening. Nowadays, a staggering 600 billion kilograms of water ice is estimated to be on our moon, roughly the same weight as 461 million cars. That's a lot of water. But how could such water be found on the moon, particularly as ice? Wouldn't it have evaporated out of space, particularly under the hot daytime temperatures? NASA's Lunar Reconnaissance mission recorded surface temperatures as high as 127 degrees Celsius on parts of the moon in direct sunlight. So, something is either generating the water, or something must be trapping it there. There are several hypotheses as to why this might be happening. Micrometeorites raining down on the lunar surface, carrying small amounts of water, could deposit the water on the lunar surface upon impact. Another possibility is that a two-step process whereby the sun's solar wind delivers hydrogen to the surface and causes a chemical reaction with oxygen-bearing minerals in the soil to create hydroxyl. Meanwhile, the bombardment of micrometeorites could be transforming that hydroxyl into water. It could then be trapped into tiny bead-like structures in the soil that form out of the high heat created by micrometeorite impacts. Or the water could be hidden between the grains of lunar soil and sheltered from sunlight. The LRO's observation means that the locations on the moon that might be viable for a lunar base is suddenly much wider. If this trace amount of water could be collected, you would not need to build your base next to a permanently shadowed region, which is convenient because PSRs are far colder than we at first thought. The moon has very little axial tilt. a little over a single degree. This means that at the poles, there exist craters that are never pointed directly at the sun. No matter what time of day or year, the sun never casts light into their mysterious basins. Naturally, a location that never sees any sunlight is bound to be cold. However, scientists were not prepared for exactly how cold it turned out these regions were. For context, at the equator, temperatures on the moon fluctuate between 120 degrees Celsius during the day and minus 130 degrees Celsius during the night. LRO houses a diviner instrument, which uses 7 thermal infrared channels to measure surface temperatures. With it, LRO found a polar crater that had temperatures as low as minus 250 degrees Celsius, making it the coldest temperature measured on any object in the entire solar system. That's colder than the average temperatures of Uranus, Neptune, or even Pluto. The crater edges shielding these areas from solar radiation might have created the perfect storage location for housing water ice, but other more interesting, useful compounds could be found there too. Carbon dioxide, carbon monoxide, dinitrogen, and argon perhaps. Furthermore, NASA's SOFIA, or Stratospheric Observatory for Infrared Astronomy, discovered water on the sunlit surface of the moon, confirming that water on the moon may not just be limited to cold and shadowed places, but distributed across the lunar surface. SOFIA found that the Clavius crater, one of the largest craters visible from Earth, has water in concentrations of 100 to 412 parts per million. To put that into perspective, the Sahara Desert has 100 times the amount of water than what SOFIA detected in the lunar soil. So yes, that is an astonishingly low quantity, and it might not be of much use to us, but it helps us in learning about the lunar surface and how it works. Water is known as the oil of space, and finding a successful, affordable way to mine it on the moon could be game-changing in the space industry. It can be recycled inside a lunar habitat and used for drinking water or washing. It could also be used to help plants grow on the moon, which are needed to nourish future lunar colonists. But the biggest and most immediate application for lunar water is making rocket propellant. Hydrogen and oxygen are 2 of the biggest materials that are used to power rockets right now. You see, getting stuff into space from Earth is a very fuel-intensive and expensive process. And the deeper into space you want to go, the more fuel you need, and the more fuel you have to carry. Having to bring all this from Earth heavily limits space exploration. But the moon has 1/6 of the Earth's gravity. So if we are able to successfully produce rocket propellant on the moon, it's less resource intensive, and transporting propellant from the moon to other locations in space would be nowhere near as expensive as transporting it from Earth. And actually, getting something from the moon to low Earth orbit is less resource intensive than sending it from Earth itself, even though that adds 300,000 kilometers to the journey. So the presence of water on the moon could help make space missions more affordable and dramatically increase our capabilities of exploring the solar system. China, in collaboration with Russia and other countries, is planning to send 3 missions by 2029 called Chang'e 6, 7 and 8, which will be targeting the South Pole, where they plan to establish by 2030 a robotic station. The US also plans to have a lunar base by 2030 on the lunar South Pole with NASA's Artemis program. They plan on launching their first non-manned flight test Artemis 1, followed by a crewed flight test Artemis 2, and finally launch Artemis 3, which will happen no earlier than 2025, and that may be our first manned mission to the moon since 1972. All in all, on the moon, the real estate market is skyrocketing. While I'm being a little tongue-in-cheek when I say that, it is evident that interest in the moon as a permanent base for human life is increasing. Before December 2022, the number of countries and political unions that had successfully sent probes either to orbit or land on the moon has risen to 6. America, Russia, Japan, Europe, China, and India have all sent spacecraft to our closest lunar neighbour. As more countries and companies set their sights on space, it may make you wonder, what's the end goal? Do we simply want to be a spacefaring species? Exploring the solar system for the betterment of humanity? Or do people smell profit in space? While researching this video, I found out a lot of eye-opening reasons why mining in space, and especially on our moon, might well be something that we see happening in the next couple of decades. Why? Well, just wait until you find out what's actually there to be mined. The first substance is known as helium-3. You may have heard of helium-3 in sci-fi stories, as theories suggest it is the ideal substance for a clean type of nuclear reactor, with no radiation and no dangerous byproduct. It also has uses in medicine and radiation detectors. However, it is really rare on Earth. It does occur naturally and can be found in deposits of natural gas, for instance, but it's generally not viable to extract, as even in natural gas, there are only around 100 parts per billion. So let's say we had 1 billion cubic meters of natural gas, you'd only be able to extract around 15 kilograms of helium-3 from it. A lot of the time, that's not economically viable. We can also produce helium-3 as a byproduct of the radioactive decay of tritium. The problem with that, though, is that tritium is a crucial component of nuclear weapons. And so when the world slowed down the production of nuclear weapons, helium-3 stockpiles also started to diminish. Assuming we don't want more tritium in the world, it means we need to find another source of helium-3, especially if technology improves enough for helium-3 reactors to become a reality. Fortunately, we have a world in orbit around Earth right now, which has been bombarded by helium-3 for billions of years, thanks to the Sun. Earth's magnetic field deflects helium-3 traveling with the solar wind around the planet, whereas the Moon, with no magnetic field for protection, simply absorbs it in the top layer of the ground. We aren't talking huge quantities, it has at most 50 parts per billion, but because it's all over the Moon, not just in tiny pockets, it can be collected alongside any other mining operation. It could also be used to power reactors on the Moon itself, which would help a moon base be self-sufficient. Some people think that helium-3 mining on the Moon will not be viable. However, China states that eventually mining helium-3 is one of the primary goals of their Chinese lunar exploration program. American, European, and Indian scientists have all stated it is something they will consider further, and Russia is conducting a feasibility study on this right now. Even private companies are eyeing up the possibility. Because the parts per billion of helium-3 are relatively low, even in the Moon's regolith, it would make sense that whoever was mining for helium-3 would also be mining for something else in the regolith at the same time. But what else can be found in it? As it happens, the lunar regolith is packed with different materials. Look at this false color mosaic of the Moon, each color indicating different deposits of minerals found on the lunar surface. There are plenty of metals to be found on the Moon in large quantities, like iron, titanium, aluminium, silicon, calcium, and magnesium. Some of these metals are locked into hard-to-access minerals and oxides. However, separating the metals will often also produce useful byproducts like oxygen and hydrogen. They are super basic and not rare on Earth at all, but unlocking these elements on the Moon itself will allow for a colony to be self-sustaining, as oxygen means breathable air, hydrogen can be converted to fuel, and combining the two will produce water. Unprocessed regolith could also prove useful, as it could potentially be turned into lunarcrete, useful for building infrastructure on the Moon without having to transport the materials from Earth. Glass could also easily be produced from lunar regolith. And while it's not super ideal, some plants can grow in lunar regolith, helping any lunar base to be self-sufficient in growing its own food, short of using hydroponics. But perhaps the most important resource found on the Moon are, ironically enough, metals known as rare earths. Interestingly, rare earths, which consist of this section of the periodic table, are not actually super rare on Earth. However, the difficulty in mining them is that they have not really collected into big deposits. Rather, they are dispersed through the Earth's crust. This means that they are exceptionally hard to mine on Earth, and there are only a few countries worldwide that have deposits large enough to do anything about it. Even then, most countries don't bother at all because of the massive environmental and human damages that come from the pollution of mining them. The only country that did not waver from these problems is China, as China has around 30% of the planet's rare earth supply. And because it is one of the only countries mining for them, they have a 95% control of the market, which puts China in a powerful position worldwide, especially seeing as these minerals are so valuable to our society, being components of various electronics and batteries. Are countries with somewhat sizable deposits like the US, Canada, Australia, and South Africa going to start digging up their backyard to extract them? Or rather than pollute the Earth further in our attempt to go green, is it actually more feasible to get these rare earths off the moon instead? Rare earths aren't any more common on the moon than on Earth, however some deposits have already been identified, and pollution on the moon would certainly not have any of the devastating environmental and human consequences attached to doing it here. As demand for these elements inevitably goes up in the coming decades, it could well be that mining for them on the moon becomes economically viable. And not only that, but a control on the market means control of the market price, and whichever country is in control will have a tremendous advantage. Will it be China maintaining their position, or will some of the other spacefaring countries and companies want a piece of the pie? Only time will tell. Which leads on to another curious question. Who actually has mining rights on the moon? Well, it's a bit unclear. The main space treaty, which most countries in the world have signed up to, is called the Outer Space Treaty, and covers things like disallowing weapons of mass destruction in space, disallowing military bases in space, and disallowing claiming any celestial body. However, it doesn't really cover mining. Other treaties have been put forward which would cover mining in space, but so far only non-spacefaring countries have signed up for it. Right now, it could just be a matter of first come, first served. This makes mapping the moon's surface and finding sources of usable lunar water all the more vital. If we intend to colonize the moon, utilizing this water will be incredibly important. However, collecting this water ice might be more challenging than you'd think. And I don't just mean the cold. There are bigger problems we'd have to face if we want to collect and use water ice and other resources from the poles. One of them is electricity. Because of the moon's low inclination, solar winds, mainly made of ions and electrons, pass by the polar regions and the terminator almost horizontally, hitting the crater's leeward. Once there, the negatively charged electrons, which are 1,000 times lighter than the positively charged ions, rush down into the crater's inside walls and bottom, causing these surfaces to become negatively charged. As the electrons rush down before the ions, a difference in charge is formed, causing an electric field to form. A negative charge is created at the bottom and inside walls of the crater, while a positive charge forms above until the positively charged ions are driven into this electric field by the electrons. As you can imagine, the most prominent separation between the two occurs at the crater's leeward, where the solar wind hits. This division between electrons and ions will eventually hit a critical level. Because of this effect, these areas could be charged up to hundreds of thousands of volts, which would have deadly consequences for an unwary explorer. But even if you avoid the poles, that might not be the end of the electrical problems you could encounter on the moon. Another occurs when combined with the fine surface dust of the moon, regolith. The moon has no magnetosphere, so any incoming solar wind directly hits its surface, causing the surface to become negatively charged, and the covering fine dust on the moon, regolith, becomes electrostatic. Regolith is a fine dust with sharp edges which can have abrasive effects. In fact, during the Apollo missions, it was reported that regolith would stick to everything due to its electrostatic charge. This could potentially damage spacesuits and instruments, which would be a huge problem. On top of that, regolith also causes some negative effects on health, causing red eyiness and cough, as it can be highly toxic. Spacesuits in the Apollo missions were made of a material called woven Teflon, which attracted the electrostatic regolith and trapped it into its material. Woven Teflon can also cause a triboelectric effect, making the astronauts a medium between the negatively charged ground of the moon and the positively charged solar wind flowing above their head. This is similar to what happens when you rub your feet on a carpet and then touch the metal handle of a door, causing you to get a small electric shock. A laboratory experiment has even proved that woven Teflon, covered in a simulant regolith, was more prone to an electric arcing. Lunar exploration would be much less appealing if you were constantly getting electrically shocked. So, if the dust and the woven Teflon made the astronauts so susceptible to getting electrocuted, why haven't we noticed before? Wouldn't it have happened during the Apollo missions? Well, this static effect can be offset when photons emitted from the sun kick off some of the electrons from the ground in a process known as photoelectric emission. This causes the ground in direct sunlight to be more positively charged and balance the negative charges brought by the solar wind. Because landers of the Apollo missions landed on a part of the moon which was constantly hit by sunlight, our astronauts had very low chances of getting electrocuted. But that's not to say it wouldn't be an issue elsewhere. So how can we keep our astronauts safe from extreme temperatures, toxic dust that could potentially contaminate moon bases, and the high chances of astronauts getting electrocuted by up to hundreds of thousands of volts of electricity? To avoid that, we would need to design a new spacesuit with dissipative properties that would never allow potentially dangerous electric charges to damage them or cause harm to the astronauts wearing them. You might think a good insulating material is rubber, and you would be right, but this would have to be balanced against the extreme temperature fluctuations these suits would have to face. After all, what would happen to rubber in an environment where temperatures could potentially reach minus 247 degrees Celsius? There are multiple undergoing projects though that are working on finding a solution to these and other problems, but so far nothing definitive has come of it yet. To avoid regolith, a team at the Washington State University was granted $130,000 by NASA on a project involving liquid nitrogen, which has properties that allow it to capture dust like regolith from surfaces, allowing lunar bases to be kept cleaner and avoid risks of getting it contaminated. NASA is also working on a technology involving electrodynamic dust shields, consisting of electrically charged panels which, through wires, shoot currents able to wipe away the regolith from surfaces. A pretty cool way of cleaning. There is also a revolutionary new technology being developed by Intention, a Norwegian tech company which is working on a project called ASG. This technology could potentially enable remote human explorations and missions by using a human-machine interface, which allows people to control rovers, robotic arms, or even machineries with the swing of one hand. They are working on including this technology in spacesuits, which could have fascinating implications for future missions to the Moon and even Mars. This would allow astronauts to stay safe inside bases while the machines are doing the job on the field. It's exciting to see different hurdles being overcome in the mission to find and gather lunar water. But while there are successes, there are also failures. In July 2024, NASA announced that it was cancelling its Volatiles Investigating Polar Exploration Rover, or VIPER, which had been intended to be the first ever mission to explore the Moon's South Pole and search for water ice. The mission was intended for 2023, but due to delays in the rover's construction and a tightening NASA budget, VIPER got pushed back to 2025 and then was cancelled entirely. The rover, now already built, may be scrapped for spare parts. This is a big blow, as no other US project over the next few years is scheduled to have the same capabilities as VIPER, which was both mobile and capable of exploring the subsurface of the Moon, not just its surface, to see if water ice could be found there. Many scientists outside of NASA were surprised at the cancellation, with some calling it a dark day for lunar science. Hopefully, another space agency or company will step in to make use of the operational rover. Otherwise, it seems to me to be a terrible waste of time, money, and expertise. But NASA is not the only space agency finding lunar exploration challenging. 5 of the previous 9 moon landing attempts have failed. But even if they had succeeded, perhaps they would have been surprised. As it turns out, lunar water, that precious resource vital for the establishment of any human colony on the moon, is proving oddly difficult to actually locate. We have repeatedly detected it in spectroscopy readings, and yet, when we take a closer look at where it ought to be, instead, a mystery appears. The established belief among scientists today is that the permanently shadowed regions of the moon are one of the most likely places to find frozen water ice. But because it's so dark down in these craters, it's difficult to know for sure exactly which craters house what. It would be unfortunate to build a scientific base, only to discover that the crater next to you was completely empty. Sadly, LRO, the NASA lunar orbiter tasked with mapping out the entire surface of the moon, has its limitations. Its onboard camera, the LROC, is not capable of piercing this darkness. But there is a new camera circling the moon that can. The reason why I said earlier that 6 countries had sent probes to the moon before December 2022 is that on the 16th of December, that number actually rose to 7. After a 4.5-month journey, South Korea's Danuri probe arrived in lunar orbit, and Danuri's discoveries provided even more insight into lunar water, as well as raising further mysteries. NASA has actually been working closely with South Korea on Danuri, providing them with scientific expertise and communications and navigation support in a spirit of mutual international scientific collaboration. In thanks, South Korea's KARI space program gave NASA 7 kilograms of space on their Korea Pathfinder lunar orbiter, or Danuri as it's locally known. A composite word made from dal, which means moon, and nurida, which means enjoy. NASA considered what scientific instrument could be best placed on Danuri, and in the end they went with a device known as ShadowCam, a younger sibling of LRO's own narrow-angle camera, with one notable enhancement. Thanks to its 200 times sensitivity, it turns images like this into images like this. This incredibly clear image is of Shackleton crater, found at the moon's south pole, the first ever site photographed by LRO. And now, thanks to Danuri and ShadowCam, we can properly peer into its inner basin. It turns out that Shackleton does not look that different from many of the other craters on the moon. Its cratered floor is covered in bumpy hummocks. But strangely, there is no obvious ice here. Perhaps this is because Shackleton is a smaller crater, meaning that the temperatures within do not drop quite so low as would be needed for ice to reliably form. One point of interest is the clear trail left by a boulder as it rolled down the crater side, visible near the top of the image. Such tracks are common on the moon, as the lack of wind means that any disturbance of the dusty ground is never covered up again. This track could be extremely old. I said that perhaps the reason no ice was found in Shackleton was because Shackleton was a small crater, but ShadowCam has now peered into many different craters in both the North and South Pole regions, and as of yet, its discoveries have only deepened the mystery of lunar water. In spite of Chandrayaan-1's findings all those years ago, none of ShadowCam's captured images showed the telltale glint of water ice, either in glaciers or as a light smattering of frost. And it only gets stranger when we consider one of the findings of India's Chandrayaan-3 mission. It was Chandrayaan-1 that first detected evidence of water on the moon's surface, But Chandrayaan-3 would take an even closer look, only for its findings to come back quite different from what scientists had expected to see. India's Chandrayaan-3 moon mission had already proven historic. It put India in the history books for being the 4th nation to ever successfully land a spacecraft on the moon, and the very first to ever land at its south pole. Sorry, Viper. The lander Vikram and the rover Pragyan already made discoveries that could profoundly impact our understanding of the moon's chemical composition and geological history, and has given the world vital data that will aid future return missions to our lunar neighbour. And yet, for all the praise, which is well deserved, it's what Chandrayaan-3 did not discover, but should have, that I find the most intriguing. Have you noticed it too? India's NASA equivalent, ISRO, the Indian Space Research Organisation, made press releases before the launch, and there was always one thing they claimed they were primarily there to find. One reason the South Pole was picked out over all other locations. One mystery about the moon that is deepening the more we investigate, and yet needs to be solved before we can expect to start setting up permanent bases up there. Simply put, where is all the water? Chandrayaan-3 was launched on the 14th of July 2023. It was made up of a lander module called Vikram, a small rover called Pragyan, and an orbiter module that carried the other 2 components across the Gulf of Space. On the 23rd of August, Vikram, with the little Pragyan tucked inside, touched down on the moon's surface at the beginning of a lunar day. But time was not on their side. Chandrayaan-3 was a surprisingly cost-effective mission. While NASA's Artemis mission launches will each cost on average $4.1 billion, the entire Chandrayaan-3 mission only came to 6.15 billion rupees, or about $75 million, ironically less than what many modern blockbuster space films take to produce. Perhaps Hollywood should consider filming their next moon film on site. However, with this lower budget came technological limitations. When the lunar night fell, Vikram and Pragyan would be subjected to temperatures of minus 120 degrees Celsius, temperatures they were not designed to survive. A lunar day lasts 14 Earth days. The Chandrayaan-3 mission would need to complete its major objectives in that time, as their odds of surviving to the day after that were slim. And so Vikram lowered its ramp, and Pragyan, the rover, powered up and headed out down onto the moon's surface. Pragyan is a 27 kilogram, 6-wheeled rover that came equipped with an alpha particle X-ray spectrometer for analyzing the chemical composition of the moon by firing radiation at it and seeing what wavelengths bounce back, and a laser-induced breakdown spectroscopy instrument that does a similar thing, but this time by firing a laser at the target of interest and analyzing the light wavelengths that are released by the resulting plasma. These 2 tools together would be enough for Pragyan to attempt to find water or any other interesting substances, confirming their composition for scientists once and for all. And so it set to work, deploying both instruments on the ground next to it. Within days, the results started to come in. Aluminium, calcium, iron, chromium, and titanium were all found on the moon's surface, along with other interesting elements like oxygen. Indian scientists were most excited at the first ever in situ measurement of sulfur at the moon's pole. Sulfur is an exciting element to find, as it helps us understand the evolution of the moon over time, and indicates there used to be volcanic activity in the region. But in spite of all these discoveries, there was one element that was not showing up in the analysis. The all-important hydrogen was notably absent. Pragyan set off to explore further afield. Guiding the rover was all done manually by scientists back on Earth, looking through Pragyan's onboard navigation camera. This had to be carefully done, as the signal delay between Earth and the moon meant that orders for the rover to halt lagged by a little under 3 seconds, time that might make all the difference if the little 6-wheeled rover was to avoid overturning. And indeed, this nearly happened. Early on in Pragyan's journey, the rover had to speedily stop to avoid falling into a large 4-meter crater scientists hadn't initially realized was there. I say speedily. Pragyan's move speed was 1 centimeter per second, hardly the fastest of sprinters. Over the course of its 2-week life, Pragyan traveled no more than 100 meters from Vikram. Fortunately, the crater was detected in time, and scientists were able to turn around and choose another route. However, when you look at Pragyan's route, you notice that there was a second moment where Pragyan did not travel down into a crater it came across, instead electing to go around. No photos of this second crater are currently available, so we are left to conclude that no ice was spotted there. Vikram itself did not remain idle during this time. It performed temperature readings of the moon's surface, digging 10 centimeters deep to measure the moon's warmth at different depths. It measured the plasma content of the atmosphere. Good news, there's not much up there, so radio communication to the moon likely won't get much interference. It detected a possible moonquake, which, given the small 2-week window, was some excellent timing. At the very end of its journey, in a moment of final enthusiasm, the Vikram lander even successfully performed a 40 centimeter high hop, firing its boosters to lift itself off the ground, moving 30 to 40 centimeters along from its previous destination. Indian scientists had wanted to test how easy it would be for future landers to one day propel themselves back into orbit from the moon, and this was a useful practice run. But none of this helped the Chandrayaan-3 mission to find water ice. By the 4th of September, time was up. Vikram and Pragyan were ordered to power down. ISRO scientists had hoped to wake them up again once the night ended, but this hope proved to be fruitless. The 2 lunar explorers had communicated with Earth for the last time. ISRO and the scientific community at large lauded their efforts and called the mission a success, and indeed it was, as India had gained first-hand data from the moon that would be extremely helpful in building a picture of conditions at its poles, along with furthering our understanding of the moon's history. However, it definitely raises a mystery. When I first heard that water ice had been detected on the moon, I envisioned in my mind frozen ice lakes, or possibly tall penitentes. Perhaps a light frost, as vapor from the moon's atmosphere ended up trapped in these darkened craters, freezing over the surface and building up over time. We know from orbiters like Chandrayaan-1 that water ice is indeed in these craters, and yet Chandrayaan-3 has joined other missions in failing to actually see this ice for themselves. Given that Pragyan's analysis of the lunar regolith revealed no signs of water molecules, where is the water ice that Chandrayaan-1 detected? While this mystery is confusing, Chandrayaan-3 offers us a possible answer. Not through Pragyan's explorations, it's actually Vikram that possibly hinted at the solution. When Vikram used its chased temperature sensor, it was able to take 10 different readings of the moon's temperature, starting at the surface and working its way down in 1 centimeter increments. What it found in the space above the moon's surface was a temperature a little under 60 degrees Celsius. Definitely too hot for you to walk around in if you happen to be on the moon and somehow didn't care about the lack of air. But curiously, as Chase measured deeper and deeper beneath the surface, this sweltering temperature dropped off fast. By 8 centimeters deep, the new temperature Vikram was detecting was minus 10 degrees Celsius. That's a big drop. From this we can see that lunar regolith is a really poor heat conductor. But that also indicates quite clearly that the best place we're likely to see ice is not resting on the moon's surface, but we actually need to look beneath it. There's much we don't understand about the moon and its water cycles. There's growing evidence that the moon contains quite a lot of water, and yet extracting it will take understanding where that water can be found, and how it moves throughout the long lunar days and nights. Is it affected by solar radiation? Is it trapped in hidden deposits? Although Chandrayaan-3 only lasted 2 weeks, which I'm sure is less time than ISRO scientists would have liked, it has offered us vital insights into the conditions on the moon. As far as water is concerned, at the very least, it has given future astronauts this one piece of advice. If you want to find a drink of water on the moon, you might want to start by bringing a shovel. Do you know the many surprising connections between the deepest parts of space and the deepest recesses of our ocean? Both are cold, dark places where humans cannot breathe and where the pressure alone is enough to kill you. Both upset our normal experiences of gravity, providing explorers with a strange weightlessness or buoyancy if they could somehow survive being there in the first place. And both contain many unsolved, captivating mysteries. Our oceans are filled with life we've never seen before. And who can say what lurks in the unexplored corners of space? I was initially caught off guard when I heard that NASA had turned its attention towards exploring the hadal zones deep in the ocean. After all, NASA is normally about space. What are they doing deep under the water and on Earth? I'm Alex McColgan and you're watching Astrum. Put on your diving gear and join me in a world of undersea facilities, uncanny life, and an environment so hostile we've mapped more of Mars than of this terrain on our own planet. In 1957, a year before NASA was founded, a paper published by the Journal of the Royal Society of Arts claimed the deep oceans covered over 2/3 of the surface of the world, and yet more is known about the shape and surface of the moon than is known about that of the bottom of the ocean. This was a reference to the fact that in the world before echo-sounding technology was commonly used to map the seafloor, we didn't know much about the topography of what was down there. We've come a long way since then, but while we have mapped the moon thanks to satellites and telescopes, we have still only mapped 23.4% of the ocean floor in high resolution. In fairness, this still represents an area of 120 million square kilometers, about 3 times the moon's surface area, so the old saying no longer holds entirely true. Hence why we can instead talk of Mars, which has a surface area of 145 million square kilometers. But still, it's a profound gap in our knowledge of our own world. NASA was founded in 1958 with the purpose of expanding human knowledge of phenomena in the atmosphere and in outer space, and developing vehicles and technologies that would help them to do so. Exploring the ocean was not originally on their radar, or sonar. However, in 1978, NASA began monitoring the ocean with their first dedicated oceanographic satellite, CSAT, which was capable of collecting data on sea surface winds, surface temperatures, wave heights, and other features. This helped them learn more about our planet's oceans and their impact on the global climate. Still, some of NASA's most exciting forays into the ocean only began at the turn of the millennium. One way in which the sea can prepare astronauts for space is through simulated space experiences. About 8.7 kilometers off Key Largo in Florida is the world's only undersea research laboratory, Aquarius Reef Base. Built in 1986, it is a small, 3-roomed habitat large enough to house 6 people at a push, with a main room that combines sleeping and living quarters, an entry dock, and a wet porch for entering the sea around it. It was originally designed to help aquanauts remain at the bottom of the sea for weeks at a time through a technique known as saturation diving. By remaining at the depth of 19 meters, the human body becomes saturated with gas dissolved in its bloodstream, which allows these researchers to stay at depth without ill effects for much longer periods of time, 9 hours for one dive rather than 1 or 2 hours. This made it ideal for biologists wanting to study the local environment in situ. In 2001, however, NASA, along with other space agencies such as ESA, realized that it made a great space training location. The cramped living conditions mimic those found on the International Space Station, so astronauts who spent a week at Aquarius Reef Base would get a vital taster of what life would be like up there. It also allowed them to practice performing experiments and generally get used to the expected and unexpected aspects of life in a hostile environment. NASA began the NEMO program, or the NASA Extreme Environment Mission Operations, and that same year began sending their astronauts to the habitat. There have been 23 NEMO missions since then, merging astronaut crews from a variety of different space agencies, which lasted up to 3 weeks. Astronauts there became aquanauts and got the chance to don deep spacesuits, getting a taste for what spacewalks might be like outside of our planet, readying them for the day humans return to the moon or go to Mars. This was not the only use NASA had for the ocean, however. Perhaps the most significant training was not for NASA's astronauts, but rather for the machines that would one day visit the largest oceans outside of planet Earth. Let's now go deeper and consider the exploration of alien oceans. Our solar system is home to many large oceans outside of Earth. Jupiter's moon Europa and Saturn's moon Enceladus, to name just two, have significant bodies of water beneath their kilometer-thick icy surfaces. In spite of only being 1/4 of the Earth's diameter, scientists believe that Europa holds twice as much water as all of our oceans combined. This is an intriguing concept, as even though no sunlight penetrates down to those depths, the mixture of liquid water bordering a rocky inner crust would make both of these locations ideal candidates for life. Scientists have considered how to best test to see if life really has arisen in the oceans of icy moons. In 2024, NASA will launch the Europa Clipper, with the mission to fly by the moon Europa and scan it to learn more about the depth of its icy shell, to try to determine the composition of its oceans and generally get a better picture of the moon as a whole. However, Europa Clipper will only be laying the groundwork for future missions, which one day might see cryobots melting through the 10-kilometer thick icy shell of Europa using nuclear-powered radiators to penetrate its oceans and see firsthand what lies below. Once down there, no radio signal will be able to reach them easily. Messages will be relayed via a vast cable brought down through the ice along with the cryobot. This means that such cryobots will need to be able to autonomously descend a further 100 to 200 kilometers to explore the dark, chilling, and highly pressurized environment they're likely to find, to see what alien life might swim in those waters. So, with a mission objective on the horizon to explore deep, dark waters in search of never before seen life, what better place to start than the unexplored oceans we already have at home? The deepest parts of the oceans on Earth are only 11 kilometers deep, but due to the gravitational differences between Europa and Earth, the pressure you'd experience between the two are much more comparable than you might think. Europa's 100-kilometer deep ocean is thought to have a hydrostatic pressure between 130 to 260 megapascals, which, if it existed in an ocean on Earth, would equate to a depth of around 13 to 26 kilometers. This is much better than if you'd had to go hundreds of kilometers down on Earth, but it's still no picnic. Pressure at the bottom of the Mariana Trench, the deepest place in our ocean, is 1,100 times the pressure on the surface, which is enough to crush the individual cells in the human body, or to implode most submarines. And yet, life survives there. And it doesn't just survive, it thrives. The deep-sea explorers of the Galapagos hydrothermal expedition in 1977, using a specially reinforced remotely operated vehicle that could survive those pressures, were shocked to discover not a barren wasteland, but thriving ecosystems gathered around hydrothermal vents on the ocean floor down there. Tube worms, crabs, and fish were found in rich abundance. As scientists performed more dives, they found all manner of strange life forms down there. Shrimp like amphipods the size of your hand, giant, ethereal, big fin squid that were 8 meters long and looked positively alien. In the depths between 6,000 and 11,000 meters, in an area known as the Hadal Zone, named after the god of the underworld, Hades, life had learned to adapt to conditions in ways no one could have imagined possible. And this incredible adaptability gives scientists a better understanding of what might be possible on other worlds. The deepest parts of the ocean are mostly found near the fault lines of continental plates, where one plate subducts under another. These deep trenches create a unique V-shaped environment that channels organic debris from above down into a sludgy pool. Whenever a carcass falls down there, the organisms in the Hadal Zone are somehow able to quickly detect it and arrive within minutes. Other organisms rely on nutrient-rich liquids pumped out of thermal vents. If you added up all these trenches into one landmass, you would end up with an area the size of Australia, a whole unexplored continent. NASA wants to explore these regions using autonomous drones, perhaps whole swarms of them that would be able to detect locations of interest such as thermal vents, and would be able to map out the terrain using cameras and onboard AI, similar to that used by the Perseverance rover on Mars. It's a challenging task. Not only would such a drone need to be able to withstand the excessive pressure, but the temperature around such thermal vents can spike to hundreds of degrees. Drones would need to be able to survive rapid temperature swings if they are able to survive. In 2014, one such deep-sea drone known as Nereus was sent into the Kermadec Trench off the coast of New Zealand. This is the area NASA has selected as testing ground for its new equipment. However, sadly, Nereus was not able to survive the pressure down there, in spite of having succeeded on Hadal dives before, and it imploded. Pieces of plastic were later found floating to the surface. NASA's latest drone is Nereus's descendant, a smaller, lighter, autonomous submarine known as Orpheus. Orpheus has yet to enter the depths of the Hadal Zone. Instead, it is being put through its paces in shallower waters. But if it works, its lighter design would make it easier to transport on a rocket to the oceans of Europa at some point in the distant future. Although, this dream might not be so distant after all. In 2023, NASA's Planetary Exploration Science Technology Office gathered a team of 40 top researchers from multiple fields in the California Institute of Technology to discuss how close we might be to making this trip. A surprising amount of technology needed is already there. Their conclusion was that the mission was feasible, scientifically compelling, and the most plausible near-term way to directly search for alien life in situ on an ocean world. With the combined information being gathered by Europa Clipper and the technical experimentation being done with Orpheus and other autonomous submarines like it, perhaps it is something we will see within our lifetimes, although no concrete plans have been made yet. When it finally does happen though, and a human-made drone starts to swim in those dark seas across the gulf of space, what will it see? Perhaps it will feel strangely like home. We are water-based life forms here on Earth. The first large, complex animals formed in our oceans. All life is dependent on water to live. Rather than arid, rocky and dusty wildernesses, there will be something strangely soothing about exploring oceans beyond our own, like entering a place we already know, even though we've never been there before. Does something lurk in those alien seas? Although it's only speculation, the sheer fact that this might be true is enough. To discover that life came to exist not once, but twice in just our own solar system would have massive implications on life's prevalence in the universe as a whole. It would mean life is likely abundant, and we ought to be ready to see a lot more of it out there. But proving it is the challenge. Only by perfecting the technology here on Earth will we be able to crack open those frozen shells, enter those inky depths, and find the definitive answers we seek. For NASA, their mission to find life in our solar system begins in our oceans. Enceladus. Perhaps one of the most intriguing objects in the entire solar system. And yet it is only the 6th largest moon of Saturn, and in natural light, it looks very unassuming. However, there's a lot more to Enceladus than meets the eye. It's an active, icy world with jets of water vapor pouring out from its southern hemisphere. Thanks to the remarkable Cassini mission, we have studied and observed Enceladus in exquisite detail, and perhaps know more about it than some of the closer and bigger Jovian moons. However, although we've seen a lot from the outside, it's the inside of the moon that still holds so many mysteries. I'm Alex McColgan and you're watching Astrum, and together we will explore some of the most fascinating details of Enceladus, piecing together photos and data from a variety of missions to find out almost everything you could want to know about this special moon. So stick with me on this journey of discovery. Let's first of all discuss where Enceladus fits into our solar system. Enceladus is currently Saturn's 14th closest moon. I say currently, as Saturn has some tiny moonlets hidden in its rings that may or may not be classified as moons in the future. It is the 2nd closest major moon though, second only to Mimas. That means that its orbit takes it just outside of Saturn's major rings. Its orbit follows the planes of the rings very precisely, and it only takes 33 hours to orbit Saturn once. Interestingly, it is in a 2-1 orbital resonance with Dione, Saturn's 4th closest major moon. In other words, it orbits twice around Saturn in the time Dione orbits once. This orbital resonance is believed to prevent Enceladus's orbit from ever becoming perfectly circular, which causes Enceladus to undergo tidal deformation. This is significant as these tidal forces heat up Enceladus's core. You see, as far as we can tell, Enceladus's surface is predominantly made of clean water, certainly with little to no rocks or much else there. Because Saturn is situated so far away from the Sun, it means the outer layer of water on Enceladus has frozen over. Enceladus is essentially a frozen ocean world, a giant ball of water ice. Because it is free from other materials on the surface, the moon is one of the whitest objects in the solar system, with a bond albedo of 0.81, which is pretty much as high as snow. As such, it is one of the coldest satellites of Saturn, with a noon temperature of -200 degrees Celsius, as the white color of its surface reflects a large percentage of the sunlight reaching it back into space. However, about 30 to 40 kilometers down under the surface of Enceladus, pressures start building, and heat energy generated from the tidal deformation of its orbit has increased the temperature of the water ice to the point where the water at this depth can exist in a liquid form. It could well be that there is an entire mantle or a global ocean of water that the ice crust is resting upon, very much like the magma mantle that our rocky crust on Earth rests upon. At the very least, scientists expect there to be a huge pocket of water under the moon's south pole. How do we know this? Well, the most obvious indication are the huge plumes of water being ejected from the cracks in the crust, something referred to as water or cryovolcanism. These jets are really active, consistently blasting around 250 kilograms of water into space every second at speeds exceeding 2,000 kilometers per hour. This is powerful enough that most of the water vapor particles escape Enceladus's weak gravity, and they end up in orbit around Saturn, forming Saturn's E-ring. This ring around Saturn is very diffuse, and so isn't really visible unless it is backlit by the Sun. From this angle, the light shining through the water particles make the ring appear exceptionally blue. In fact, this ring is considered the bluest object in the solar system, even more so than Neptune due to the ring's uniformity. The E-ring is Saturn's second outermost ring, and it is 2,000 kilometers wide. Its shape is also heavily influenced by the orbit of Enceladus. Enceladus's plumes create tendril shapes in the rings as more material erupts out of it. However, these sections of the ring tend to smooth off as Enceladus moves further away along its orbit. During the course of Cassini's mission, Cassini was able to pass through these plumes to detect the substances being ejected from them. Cassini wasn't designed with this in mind. Scientists didn't know about the plumes until Cassini got there. However, Cassini was equipped with an instrument called the Cosmic Dust Analyzer, designed to detect what the tiny dust grains in orbit around Saturn are made of, and it was able to use it for Enceladus's plumes too. As it wasn't specifically designed with this in mind, it might not have given us the full picture of what's in these particles, but while water was the predominant substance detected, amino acids, carbon dioxide, nitrogen, and methane were also found. Amino acids are significant as they are the building blocks of life and can be found around the thermal vents at the bottom of Earth's oceans. Does this mean Enceladus has thermal vents of its own? And if so, do they have ecosystems of life around them? While evidence for an underground ocean is abundant, scientists still aren't completely sure about Enceladus's internal structure. At some points in the past, scientists believed that Enceladus was water all the way through. However, data from Cassini suggests that Enceladus's mass is in fact greater than previously thought, meaning it must have some amounts of iron or silicate material in its core. Scientists are starting to lean towards the theory that the internal structure is differentiated, meaning it's a celestial body with defined layers within it. An object of this size really doesn't have to be differentiated. In fact, it's so small at only about 500 kilometers across that it is right on the borderline of being in hydrostatic equilibrium, or in other words, being rounded by its own gravity. There are a number of objects out there of similar or smaller sizes that are not in hydrostatic equilibrium, like Neptune's Proteus. In any case, assuming it does have a differentiated interior, this core is likely to be predominantly rocky. This is important, as thermal vents in Enceladus's water ocean would have to come from a rocky core. A rocky ocean floor would also provide nutrients and minerals essential for what we believe life would need to form and evolve. Thermal activity clearly does exist due to the way Enceladus has plumes in the first place, and the amino acids detected in the plumes suggest a rocky core. As Cassini passed over Enceladus, it also mapped out the thermal emissions from the moon. It turned out that the jets line up with what has come to be known as Enceladus's tiger stripes. These are large depressions, roughly 130 kilometers long, 2 kilometers wide, and 500 meters deep. It is believed that these are tectonic fractures in the moon's icy crust. What is really interesting about the surface features of Enceladus is that there are virtually no impact craters at all over the southern hemisphere, and not many anywhere else. This implies that Enceladus's surface is very young, as while it does have a thin atmosphere made up from the ejected water from the plumes, this isn't nearly enough to burn up asteroids before they hit the surface. Some water from the plumes obviously settles again on the surface, which smooths it off over time. This is another reason why Enceladus is so round for such a small celestial body. In fact, apart from the tectonic fractures and few craters, Enceladus's topographical variation is really quite minimal. There are no mountain ranges to speak of, although there is what you might call a rough terrain around the South Pole if you zoom in far enough. This is perhaps the highest resolution image we have of its surface, and as you can see, it really does appear like a giant glacier. It's interesting to note that even in this small view, there are some smooth sections of ice, but also jagged regions. Over the North Pole, the clear difference is the number of craters present there. While there are tectonic fractures here too, there are no plumes on this side of the moon, so the surface here is clearly a lot older than around the South Pole, which is why it has more of a cratered surface. As Cassini flew through the plumes around the South Pole, it also took the opportunity to image the surface closely around the tiger stripes. The surface here is pretty incredible, unlike anything you would have seen on Earth. It's like the surface has been folded, squashed, and shifted around, leaving these remarkable fracture lines and formations in the surface ice. The fact that Cassini was able to get so close to Enceladus is a feat in and of itself. It's fantastic that we can have such a close-up view of something so far away. Unfortunately though, since the Cassini mission has ended, we no longer have anything in orbit around Saturn that can study Enceladus further. There have been plenty of mission proposals in the past, but all of them were cancelled before they came to fruition. What would be incredible is a probe that could either make its way into Enceladus's ocean somehow, or at the very least, search the plumes for signs of life. There is already a mission called Dragonfly going to the nearby moon of Titan, however this won't have anything to do with Enceladus. So, although a couple of mission proposals are currently under review to go there, that means we are unfortunately still a couple of decades away at least, which is a shame because who knows what secrets lie in wait under that crust. So, there we have it, a look at the intriguing little moon of Enceladus. Europa, one of the most exciting moons in the entire solar system. It is a beautiful world filled with mysteries. This is the first ever close-up image of Europa, taken by the Pioneer probe back in 1973. Since then, we've had the Voyager and Galileo probes explore the moon, and with each visit, Europa has never failed to surprise us. We are yet to solve a lot of Europa's puzzles, but there are many things that we are starting to piece together. I'm Alex McColgan, and you're watching Astrum. Stick with me in this video, and together we will explore some of those fascinating mysteries and delve into almost everything there is to know about this intriguing world. Let's first of all see where Europa fits into the Jovian system. Europa is the second and smallest of the 4 Galilean moons, although it's still the 6th biggest moon in the entire solar system, just behind Earth's moon, with a diameter of about 3,000 kilometers. It takes Europa 3.5 days to orbit Jupiter once. Interestingly, the first 3 Galilean moons, Io, Europa and Ganymede, are locked in a 4-2-1 orbital resonance due to their gravitational influence with each other. This means that every time Ganymede orbits Jupiter once, Europa orbits twice and Io orbits 4 times. This orbital resonance and the constant gravitational tugging from the other moons keeps the orbit of Europa from ever becoming completely circular. Due to Europa's slight ecliptical orbit, the magnitude of the gravitational force acting on it from Jupiter increases and decreases as it orbits. This creates tides that stretch the moon's surface. These forces are significant as they have a big influence on the moon's appearance and what goes on under the surface. Europa's surface is made predominantly of water ice. As you can tell, it looks very remarkable and distinctive due to these long, continuous fractures and cracks. These are called lineae, which translates to lines in Latin. These lineae are often only about 1 to 2 kilometers wide, but can extend for thousands of kilometers across the moon's surface. We aren't sure how or why these lineae are formed at present, but the most likely theory is that as the crust pulls apart from tidal flexing, warmer material from beneath fills the gap, in a similar fashion to the ocean ridges on Earth. In this image taken by the Galileo spacecraft, you will notice some dark brown spots. They are very small, only about 10 kilometers across, and they are known as lenticulae. They are also believed to be formed by the upwelling of hot, less dense material to the surface, either by pushing the existing crust up or by breaking through altogether. Should the underground material have broken through, what we can then see are these strange, unusual terrains called chaos terrains. They are really rough patches surrounded by a rather smooth surface. These spots are expected to be soft and may contain significant information about what's under Europa's surface, which we will get to later in the video. Data from Galileo also indicated that Europa's equator may be covered in icy spikes called penitentes. These vertical cracks may be up to 15 meters high and will have formed from direct overhead sunlight on the equator. Interestingly, penitentes are found on Earth too, in dry regions at high altitudes, although nowhere near as large as on Europa. Despite being roughly the age of the solar system, Europa barely has any craters. Europa has less than 50 major craters, whereas the Earth's moon has more than 5,000 craters with a diameter above 25 kilometers. This indicates that Europa's surface is constantly changing and reforming. Models suggest that Europa's surface is only about 30 to 180 million years old, which is very young in geological terms. Additionally, Europa's icy surface is the smoothest surface of any known solid celestial object in the entire solar system. Its icy crust also has an albedo or light reflectivity of 0.64, one of the highest of all the moons. Europa's albedo makes it 5 times brighter than our moon. The surface is bombarded by a constant and intense blast of radiation from Jupiter. The radiation level at the surface of Europa is equivalent to a dose of about 5,400 millisieverts per day. Exposure to radiation at that level would be enough to kill a human in a single day. The reddish-brown color spread across the cracks and fractures of the moon is believed to be due to salt and sulfur compounds mixing with water ice and then modified by Jupiter's radiation. A recent study from JPL suggests that Europa might even glow in the dark. Energetic ions from the radiation penetrates the surface, which would energize the molecules beneath, which would make them release energy as visible light. Unfortunately, we cannot see Europa's dark side from Earth, as we are between it and the Sun always. So we are going to have to wait for future missions to Europa before we can prove this. Radiation received from Jupiter plays a significant role in Europa's atmosphere as well. Europa has a very tenuous atmosphere, composed primarily of oxygen. Unlike on Earth, the oxygen on Europa is formed by radiolysis, or in other words, the process of radiation bombarding the water ice surface, separating the H2O into oxygen and hydrogen. Hydrogen escapes Europa's gravity altogether because it's so light, whereas a lot of the heavier molecular oxygen remains. The hydrogen and oxygen that escape Europa's gravity form a dispersed neutral cloud, which follows the orbit of Europa around Jupiter. In 2012, the Hubble Space Telescope discovered plumes of water vapor erupting from Europa's south pole. This image suggests that the water plumes rise up to 200 kilometers from its surface. In 2018, astronomers found additional evidence of water plume activity on Europa when they looked back at the old Galileo data with a new data analysis technique. A dedicated mission studying these plumes can also help us understand what's inside the moon without having to land on it. Because what may lie underneath that solid ice surface is perhaps the most fascinating thing about Europa. There is likely to be a global ocean between a rocky mantle and the water ice crust. The first clue that this amazing ocean world was hidden under its surface was provided by the Voyager and Galileo probes in 1979 and the late 1990s respectively. Between these missions, there was a drastic change in the magnetic field of the moon, which is not possible unless there is some electrically conductive fluid beneath its surface. Europa's crust also indicates the presence of a liquid layer beneath it, as it rotates with an angle of 80 degrees, which is not possible if the crust and rocky mantle were mechanically attached. Instead, it is likely that the icy crust floats on the ocean, and it is believed to make one full rotation around the moon once every 12,000 years. The fact that this ocean is not attached also explains the multitude of lineae on the surface. Tidal flexing should cause lineae to form at specific points on Europa, not all over. However, because the position of the crust changes over time, and one spot never stays in the same place for long, hence why more and more lineae form. Europa is 780 million kilometers away from the Sun, which is 5 times further away than the Earth. That makes the sunlight about 25 times fainter here. As such, Europa, or any other moon in the Jovian system for that matter, barely receives any heat from the Sun. So unsurprisingly, it's cold enough here that the surface is frozen. In fact, Europa's surface temperature averages about minus 160 degrees Celsius at the equator and minus 220 degrees Celsius at the poles, keeping Europa's icy crust as hard as granite. However, tidal pressures exerted on the Moon as it orbits Jupiter heats Europa's core, so geothermal activity from the core should keep the subsurface ocean in a liquid state. This ocean is believed to be under only 15 to 25 kilometers of solid frozen crust. The ocean itself is probably about 60 to 150 kilometers deep. Interestingly, Europa is only 1/4 the diameter of Earth, although it may contain twice as much water as all of Earth's oceans combined. What's most interesting about Europa's ocean is that scientists believe that it is in contact with Europa's silicate rocky mantle. This makes Europa's ocean a suitable environment for life as we know it to exist. We believe that life requires water, minerals, and energy to form, and Europa seems to have all these requirements. From the evidence we've seen so far, scientists are extremely confident that this ocean not only exists, but that chemical reactions can take place there, and that there is enough tidal energy heating the core that geothermal activity may exist on this ocean's floor. As we have seen on Earth, whole ecosystems can exist in such places, far from the sun's light. So for now, Europa is one of the most likely places we can find life outside of Earth. Now, NASA's Europa Clipper spacecraft is scheduled to launch in 2022 and is likely to reach the Moon by the end of the decade. It is scheduled to perform more than 42 flybys of Europa. ESA is also working on their own spacecraft called JUICE, or Jupiter Icy Moons Explorer, which will explore Jupiter and 3 of its largest moons, Ganymede, Callisto, and Europa. JUICE is also scheduled to launch in 2022 and is also likely to reach the Moon by the end of the decade. These probes are specifically designed to examine Europa's water plumes and atmosphere. NASA is also planning a Europa lander mission, but this mission is going to launch well after the Europa Clipper mission. These missions will help us know more about Europa and hopefully confirm the answer to the most tantalizing question of all: does it and can it sustain life? At the very least, these missions will give us a new perspective of our solar system and help us understand how it works. So there we have it, almost everything you could want to know about the fascinating world of Europa. A massive thank you to our astronauts on Patreon. This video had no sponsors, but it was still made possible thanks to the hundreds of members we have there. Link is in the description to join our growing community. Patreon is where Astrum truly takes shape, a place for people who love space, who want to see these videos keep improving and reaching more curious minds. Every new member keeps the channel focused on what really matters, making the complexity of space available to everyone. If you enjoy what we do, come join the Astrum community today.